Okay, so we're going to get three similar results just by using the symmetry of A, B, C here. So similarly, square root ABC less than or equal to, and we're going to switch what's at the back here. So let's go B squared plus C squared plus 2A on 4, and square root ABC less than or equal to, and now we're going to switch what's at the back. We haven't had to go with 2b at the back, which means it's a squared plus c squared plus 2b on 4. And then the trick is then to add the three results. And let's see what we get. If we add the left hand side, we'll have 3 lots of square root ABC. And if we add the right hand side, convince yourself you've got 2 lots of a squared, 2 lots of b squared, 2 lots of c squared. So 2 lots of a squared plus b squared plus c squared. And you've also got 2 lots of a, b, and c. Okay, on 4. Okay, and we can cancel that, change that to a 2, and we can divide by 3, and then I believe that is the answer. Okay. Yep. So that one there required us to use symmetry, just change the values of A, B, C around, use some symmetry, get 3 results, and then add. Okay. Alright, page 12. This comes from NESA topic guidance. Given that x plus y is p, prove that if x is greater than 0, y is greater than 0, then that. One question to raise is, can we use AMGM without proving it? And I would say don't do that. Don't risk it. Okay, so and the simple reason why I say don't risk it is usually they tell you in the HSC when to use it. They'll give it to you, or they'll get it to prove you in part I. So never take anything assumed. Okay, and so I'll just quickly let's quickly derive it. Let's remember how to derive it. So you would look at square root of x minus square root y, all squared greater than or equal to 0, x and y greater than 0. So x minus 2 square root xy plus y is greater than or equal to 0. So x plus y is greater than or equal to 2 root xy. Okay, so that's your AM greater than or equal to GM proof for 2 numbers. And now I'm going to apply that here. So if I was a bit smarter, I might have used different letters, but that's alright. I'm going to change x to 1 on x and y to 1 on y, and that's allowed because we still keep that 1 on x is positive and 1 on y is positive, so we can still apply it. So what do we get? We get 1 on x plus 1 on y greater than or equal to 2 square root 1 on x, 1 on y. Okay. Now that is not what they've given us. Alright, what they've given us is they've given us this. X plus y is equal to p. Okay, so if I actually apply that here, I can say I'll call it 1 maybe. We'll come back to that one. So we've got x plus y is greater than or equal to 2 root xy. We'll get the p in there. Alright, now I want it to be 1 over, so maybe I just need to manipulate a little bit. I'm going to keep the greater than or equal to, so I want it to be a 1 over root xy greater than or equal to 2 on p. Now p is greater than 0, so that doesn't change the inequality sign, and obviously square root xy is greater than 0, so it doesn't change the inequality sign. Now I'm going to use I'm going to use combining 1 and 2. So we've got A is greater than or equal to B, and B is greater than or equal to C, so we can kind of apply that. I can basically substitute in 2 on P here, and we can get the required result using 1 and 2. We get the required result. Okay. Alright, so that's the first bit. We also want to show something with 1 on x squared. So let's use the am greater than or equal to gm. Let's use this, but with x being 1 on x squared and y being 1 on y squared. So we're looking at this part of the question now. So let's do that. We'll get a 1 on x squared plus 1 on y squared is greater than or equal to 2, and then it'll be square root 1 on x squared times 1 on y squared, which is going to be greater than or equal to 2 on xy. Okay. I want to have an 8 on p squared. Let's have a look. What can I do? So let's have a look at equation 2. Because I know both these parts are positive, I can square it. So from 2 squared, we get that 1 on xy is greater than or equal to, that'll be 4 on p squared. So applying that there, we'll get 1 on x squared plus 1 on y squared greater than or equal to 2 times by 4 on p squared, which is your 8 on p squared, as required. Alrighty. Next one. If A, B, and C are positive real numbers, maybe use AMGM, and the product is equal to 8, find the minimum value of this. Okay, so sum of 3 numbers. I'm going to just blindly assume that we can use AMGM for 3 numbers, okay? There'll probably be a bit of hint or guidance earlier on in the question that we can use AMGM for 3 numbers. And what I'm going to do is I'm going to make the 3 numbers A, 2B, and 3C. So that'll be greater than or equal to 3 times the cube root of the product of those numbers. So that would be A times 2B times 3C. Okay, and let's remember that this is a minimum when the 3 numbers are equal. So the 3 numbers, I might write the 3 numbers A, Y is 2B, and Z is 3C. Okay, so let's simplify this. This is cube root, that'll be 6ABC. Okay, so, and we know that ABC is equal to 8. Ooh, cube root of 8 is 2. Okay, so cube root of 6 times 8, and cube root of 8 is 2, so we can pull the 2 out, and that'll be 6 cube root 6. So if I want to find the minimum value will be the equal to case. So minimum value when A is equal to 2B, which is equal to 3C, is 6 cube root 6. Now, sometimes it's important to check. We should probably check: is it possible? Check if possible, and I think part 2 actually gets us to kind of work out the values of A and B and C that give the minimum. So, but it's good to check because sometimes this condition here is not possible, and therefore the minimum won't be this; it'll be something higher. Okay, so let's find. So the answer for I is 6 cube root 6, but let's see if we can find an A, B, and C. So if A equals to 2B equals to 3C, just adjusted here. I've just written down the sum here and make it a bit easier. So if 2b is also a and 3c is also a, this here becomes 3a is equal to 6 cube root 6 dividing by 3. I get a must be 2 cube root 6. We want to find, and that obviously equals to 2b. So therefore b is going to be cube root of 6, and a also equals to 3c. So that's going to be c is 2/3 cube root of 6. So therefore we got our values of a, b, and c. I won't rewrite them, I'll just box them. Okay, but you should probably rewrite it. Okay, pushing on. So so you can use AMGM to work out some minimum values and also maximum values. Now let's have a look at another example. This one's an interesting one. I like this one. It's a bit different. Got to think carefully for this one. Okay, if x and y are positive real numbers, show that, and then we got an expression. Okay, it's looking like AMGM for two numbers twice. Let's just assume somewhere in the question it mentions that we can use AM greater than GM. It says that we can use A plus B on A plus B is greater than or equal to 2 root AB. Let's imagine that that's in the question. Okay, so I'm going to let A be 2x, B be 3y. Sub it in. You get that 2x plus 3y is greater than or equal to 2 lots of square root the product, and the product is 6xy. And I'm also going to let A be 8 on x and B be 3 on y, in which case we've got 8 on x plus 3 on y greater than or equal to 2 square root. If you multiply these two together, it'll be 24 on xy. Okay, let's call this 1, let's call this 2. The obvious thing to do is to multiply these two together, and you'll definitely see the pronumeral cancelling, which is nice. So 1 times 2 is going to be 2x plus 3y times 8 on x plus 3 on y. Greater than or equal to, that'll be 4 square root 6xy times 24 on xy. Xy's cancel. Okay, and 4 times 24. Sorry, 6 times 24. It should be 144. Square root of 144 is 12, so that's going to be 4 times 12, which is 48. Okay, just for time's sake, I'm going to imagine I've written the same thing. So that's A. Now this is interesting. B says explain why we can't equal to 48. So we know we're greater than or equal to 48. We want to explain why we can't equal to 48. So to equal 48, we would have to have, in both cases of using AMGM, we would have to have the numbers equaling. Remember, all the numbers in AMGM have to equal each other. So we'd have to have, so AM equals to GM when A equals to B, right? So therefore we would have a situation where 2x equals to 3y. So actually I'll write if this guy was to equal 48, then this would have to equal to this when we used AMGM, and this would have to equal to this. So we'd have 2x equals to 3y and 8 on x equals to 3 on y, which is equivalent to 8y is equal to 3x. So we've got two equations that, and we're going to see something interesting. We're going to see that there's no solution to these two equations, so therefore we can't equal to 48. So let's try.